Alrighty, folks. Today we are going to continue our discussion by talking about power. And to start off here, I've got one of my favorite memes of all time, and that is from Dragon Ball Z. It's from when Vegeta and Goku are fighting for the first time, and Vegeta is shocked to find out that Goku's power level is over 9,000. So, we are going to be talking about power. Power kind of means something very different in the Dragon Ball Z universe, but we are going to talk about the physics definition of power today. Alrighty, our learning target for today is I understand what power is, how it is related to work, and how to calculate it with proper units. Alrighty, folks, so here's our agenda for the day. First and foremost, please go and take Quick Quiz 3.1. That is in your Schoology folder, so go ahead and check that out. After that, I want you to go ahead and set up your notes. Your topic for today is power, and your essential question is, how does work relate to the amount of power used? After that, we're going to take power notes, and then we are going to have an opportunity for you to do some practice and also learn some more on your own with tutorials and a worksheet. So go ahead and get the quick quiz done for attendance and get your notes set up. All right, let's go ahead and start off by talking about what is power. Power is how much time it takes to do work. So we talked about work the other day, and we know that work is force applied over a distance. So you have to have a force, and that force has to cause an object to move in the direction of the force. Power just measures the time that it takes as well. And if you think about it, any sort of motion or action requires power because force, distance, and time are all involved. Over here, you see a couple of folks, and they are pushing a car. So you see a couple of things are involved. First off, because they are pushing, that means that there is force involved. You can see that the car is moving, and therefore there is distance involved. And because there is force and distance involved, that means that there is work done. But the fact of the matter is, there is also a time involved. So if we start from the beginning of the clip here, we have about 4 seconds or so of time involved. And so because time is involved as well, that also means that power is involved. What question does the previous slide answer? All right, so let's talk about how work and power relate to each other. So power is the rate of doing work. All right, so what does that mean? Well, if you do work faster, then it requires more power. All right, so remember that work is the force applied to an object and the distance that that object moves. And so anytime you cause an object to move, there was work done. And so the question is, how long did it take you to do that? And if you do your work faster, it requires more power. So to increase power, you can do two things. You can increase the amount of work done in a given time. So more work over the same amount of time, more power. Or you can do the given amount of work in less time, and that would also increase the power. So let's use shoveling snow as an example here. So the same amount of work is required to clear a driveway of snow. No matter what you're doing, you're going to be moving a certain object, the snow in the driveway, a certain distance. Okay, so you're going to have to apply the force because the snow has a certain mass. That means there's a certain force involved and to remove it, and you're going to need to move it the same distance. So what that means is the same amount of work is going to be required no matter how long it takes you to clear the driveway. So there are 3 ways you could approach clearing the driveway. You could shovel, and shovel is going to be low power because it's going to take the most amount of time. All right. A snow blower is going to be medium power because you are doing the same amount of work in less time. The snowplow, or if you got a snowplow, that is going to be high power because you are doing the same amount of work. You're clearing the same amount of snow, but you're doing it in the least time. So as we decrease that time involved, the power goes up and up and up. And so a snow plow is a lot more powerful than you sitting and shoveling the snow out of your driveway. So in this example, you have the same amount of work done, it's just less time for each. Or you could also think about it as if you only have so much time, more power gets more work done. So let's just turn this around. Let's just say that for some reason you only had 5 minutes to clear your driveway. So if you shoveled, you would only get maybe 10% of your driveway cleared. If you use the snow blower, maybe you get about 25% of your driveway cleared. And if you use the snow plow in that 5-minute time, you get the entire driveway cleared. And so in that case, you had a certain amount of time and you just got more work done in that time. So once again, we see by having higher power, you get more work done. So those are different ways to approach it. But as we are saying, as you increase power, you increase the amount of work done in a given time, or you do the given amount of work in less time. What question does the previous slide answer? All right, folks, so all of this is to say that we can actually calculate power. And once again, shocker, we can use our formula triangle because power equals work divided by time. So right here is your formula triangle. Feel free to copy that down into your notes. So our unit for power is actually going to be called the watt, okay? And watts equals joules, which is what we measure work in, and over seconds, which is what we measure time in. Watts equals joules per second. This is once again going to be one of those units that you need to make sure that you simplify. If you answer a power equation with the unit of joules per second, that will be incorrect. You need to simplify that to watts. So what exactly does watts mean? What does it mean for something to have that much power? So let's use, for an example, a 40-watt light bulb. Okay, so this is just like your standard light bulb that you'd find in a table lamp. A 40-watt light bulb requires 40 joules for each second that it is lit. So what that means, that is actually going to be electric power, which is actually very much the same in a sense as physical power. This would actually be the same amount of power as lifting a textbook 1 meter in a half a second, okay? So the power that you exert lifting a textbook 1 meter up in half a second, that amount of power would actually light a light bulb for a 40-watt light bulb for 1 second. And so it just is, your power is in a different form. But that kind of gives you an idea of what we're dealing with here. Now, a lot of you actually may be more familiar with another unit of power that we are not going to use in this class, but I do want to make you familiar with it, and that is the horsepower. So horsepower is oftentimes engines and motors are measured in horsepower, and 1 horsepower is equal to 746 watts. So James Watt was the scientist who came up with a lot of the work behind power, and he wanted to express the power of steam engines, which is what he was measuring, and horses were the common source of power. And so the term, or the unit of horsepower, is based on the power output of a very strong horse. What question does the previous slide answer? All right, folks, so in your packet, you are going to find a power worksheet. So I'm going to go ahead and walk you through a problem, have you do a couple of practice problems, and then we'll get rolling. So problem number 1 on your worksheet is, if you do 300 joules of work in 5 seconds, what is your power? All right, well, it's asking you right off the top here to identify power, so that's our unknown. The work is 300 joules. We know that it says right there in the problem, 300 joules of work. We also know joules is the unit for work, so work equals 300 joules. And 5 seconds is a time, so we do time equals 5 seconds. Since we are solving for power, and we see our little formula triangle over here, if we cover up power, we're left with work and time, work divided by time, and there you go right there. So we go ahead and plug in 300 joules for work, 5 seconds for time. Power equals 300 joules divided by 5 seconds, and that then means that power equals 300 divided by 5, which is 60 joules per second, which we simplify that unit into W, or watts. So that is going to be how you do that problem. What question does the previous slide answer? All right, folks, I want you to go ahead and pause this video and try to answer questions 2 and 3 on your power worksheet. Question 2 is, if 68 watts of power is produced in 14 seconds, how much work is done? And number 3, if a runner exerts 350 joules of work to make 125 watts of power, then how long did it take the runner to do the work? Pause this video, try these problems on your own, and then come back for the answers. All right, so for problem 2, you should have gotten 952.0 joules, and for problem 3, you should have gotten 2.8 seconds. If you got those correct, that means that you are right on track, folks, and you're ready to go with some more practice problems. If you did not get those answers, then I'm going to direct you to check out the math tutorials that I have available. So, in general, if you have questions about power, make sure to submit a question to our class discussion. And as I said, watch the video tutorials on Schoology to see those practice problems work. And as always, we can go through and figure out where you are struggling if you want to connect with me. Alrighty, folks, on a scale of 1 to 5, I would like you to self-assess. How well do you understand power? 1 is you are super lost. And actually, instead of 5, we're going to go over 9,000 because no one can stop your power. Go ahead and self-assess. Alrighty, folks, so here's what I want you to do. If you rated yourself at a 1 or a 2, you should be watching your video tutorials and going through how to do your power problems. Also, maybe set up an appointment with me during office hours for help. If you got 3 to over 9,000, I want you to go ahead and do some practice and check your answers on the key. Do as much practice as you need to in order to be successful, and make sure that you are checking your answers as you go along. Alrighty, folks, have a great day.